In this example, when a factory operates from 6 a.m. to 6 p.m., its total fuel consumption varies according to the formula F at T equals 0.9 T squared minus 0.3 T to the power 0.5 plus 20, where T is the time in hours after 6 a.m. and F of T is the number of barrels of fuel oil. In part A, how much fuel oil is consumed by noon? In part B, what is the rate of consumption of the fuel at 10 a.m.? And the last one, what is the average rate of consumption from 6 to 2 p.m.? So I would like you to make observation of 3 different subproblems here. In part A, the key term by noon, that means T is 6 or 6 hours after 6 a.m. The problem asks for how much fuel. That means you are looking for F at T when T is 6. Well, when you put these 2 key terms together, you are asked to find what is F at 6. In part B, question asks for the rate of consumption at the point of time 10 a.m. That means when T equals 4 or 4 hours after 6 a.m. Another key term, the rate of consumption, similar to part C, asks for rate of consumption too. But in part C, there's another term like average. So that means these two are not exactly the same. In part B is understood to be the instantaneous rate of change, or ask for the derivative or f prime of the T when T equals 4. When you put them all together, that means you're gonna find out what is f prime at 4. Let's put the question mark here, so we can see the differences between A and B, B and C. And then for part C, rate of consumption but average at the 2 different points of time. If you recall, the average rate of consumption or average rate of change is the same as the slope of the secant line. So this is the slope of secant line. Similar to this is the same as the slope of the tangent line. Tangent derivative, secant, normal slope formula, 2 different points of time. At 6 a.m., T equals 0. At 2 p.m., T equals 8. Okay, when you set it up, that means you are looking for F at 8 minus F at 0, all divided by 8 minus 0, which is the use of the slope formula for part C to represent the average rate of consumption from from one point of time to another point of time. Now, as you see 3 different problems, there are key terms to help you identify what function or what are you looking for and how do you set it up. Now back to part A. Since part A asks you to find the f at 6, what is the f function? The f function is, I'm gonna write in different color to make it different than the setup that we put together. So that means f at 6 is computed by 0.9 multiplied by 6 to the power second minus 0.3 times 6 to the power 0.5 added by 20. Put in a calculator. So let's leave it in 2 decimal places. So it turns out to be 51.67 and unit is barrels of fuel oil. So let's write it down, barrel. So we get the answer in part A. In part B, what is the rate of consumption of the fuel at 10 a.m. or at 4? So we need f prime at 4. First of all, if f of t is given by 0.9 t squared minus 0.3 t to the power 0.5 added by 20, therefore the f prime or the rate of consumption is the derivative of these 3 terms. Use the concept multiple rule, 0.9 times the derivative from using the power rule. Power 2 is going to be t to the first power minus 0.3 concept multiple times the derivative from the power rule, power 0.5, t now to the power 0.5 minus 1, and then added by 0, which is the derivative of 20, and then simplify to be 1.8 times t subtracted by 0.3 times 0.5 or 0.15. The power of the second term is negative 0.5 from simplifying 0.5 minus 1. Now you have the derivative or the f prime at t. We are looking at f prime at 4, so we're at 10 a.m. That means when t equals 4, f prime at 4 equals 1.8 multiplied by 4 subtracted by 0.15 times 4 to the power negative 0.5, and then put in the calculator. Again, if we leave two decimal places, we get 7.13. Unit is going to be the unit of the rate of consumption, rate of change. The numerator is the total consumption, which is barrel, okay, per change in time, the time in hours, so per hour. So every 1 hour, there will be the increasing of the rate by 7.13 barrels. Alright, let's do the last one. So we got the setup. That means we're gonna need F at 0, F at 0. We're gonna need F at 8, and then put them back into the setup that we did earlier. Recall the f of t is given by 0.9 t squared minus 0.3 t to the 0.5 plus 20. That means f at 0 gonna be 0.9 times 0 minus 0.3 times 0 plus 20, or simplify to be 20. And then for function value at 8, it's going to be 0.9 times 8 squared. Well, 0 squared and 0 are the same. And then subtracted by 0.3 times 8 plus 20. This is the intermediate calculation process. So we're going to leave more decimal places. I have 76.751472. If you recall earlier examples in other sections that we learned before, most of the problem asks you to leave the intermediate calculation to be like at least 6 decimal places. So let's keep it 6 decimal places for the terms or the numbers that we needed. And then we bring it over to perform the computation for the slope of the secant line, or the one that represents the average rate of consumption. So f at 8 is 76.751472 subtracted by 20, all divided by 8 minus 0. Make sure you put parentheses around the quantity on the numerator, and then put in the calculator, and it turns out to be 7.09 if we keep 2 decimal places as the final form of the answer. It's about the rate, so gonna be the quantity of the change in barrel, so the numerator gonna be unit in barrels, and then divided by the change in time, the 8 hours difference, so time in hour. So this is the average rate of change for the consumption. If 1 hour change, the average gonna be about the increase in 7.09 barrels.